All right, we're going to go ahead and look at a little bit of error analysis. And I realize this probably looks different than your notes, but I still have the key features table with some potential answers and a little bit of space here of explaining if they're true or false, making some corrections. And then I took the graph and I just duplicated the image there so that I can talk about some of these qualities over here, and then once I get to the bottom I have fresh space. So if we go ahead and kind of look at this curve, it's doing some interesting things. Takes a little dip and then goes up and outwards kind of on this small graph. And the first key feature, saying the x-intercepts, gives us the coordinate 0, -1. And if you kind of remember, the first number is the x value, so we're going over 0, and the -1 is its height, which that would not be where this point is. So if we correct that, really should have those two things switched around. So that is false, and it is -1, 0 as its corrected point. The y-intercept, unfortunately something similar is happening. It is not 2 units over 0 units up, 2, 0. That would be wrong. It's 0, 2. So often students kind of just get things goobered up occasionally and mix the order. It's x and then y values for every coordinate. Relative maximums and minimums are coordinates. They are points in space. Remember, it's the hilltop and it's the valley bottom. Potentially, you could have an end point, so it would be like a cliff or a ledge, but it would be high and low, respectively. And it says the maximum is 4, 4, over 4 and up 4, really pointing at that location. And because the curve here continues to go up and up and up and up forever within this bubble, that dot is actually not a relative maximum. You could find a point that is just a little bit taller and just a little bit taller within that bubble. So there is no relative max. That would be a good correction. The minimum, it says -3, -2. If we travel left 3 and down 2, water would collect in that location. And so within this bubble and that boundary, there aren't any points that are lower than that. So this one looks good to me. All right. Increasing and decreasing, these go together. It's like riding a roller coaster, so going up and going down a roller coaster. And it says that we start increasing or going up from -3 to infinity. So if I go ahead and cut things here at -3 as an x value, does my graph start going up and up and up and up from that point onward? And it seems to be in agreement. If I go ahead and color the curve up being like green, that action is going to continue indefinitely, so that looks really good to me. The decreasing, the interval here says -infinity to -2. And again, I know it's an interval because it's using this x notation. If you don't put an x in front, just like up here, it's a point. But having an x in front means that this is an x value and that is another x value. So -infinity means all the way over here, and then to -2 actually cuts off here. And do you notice how there's overlap between -3 and -2 that got counted twice? And I'm not really sure why that happened. So that would be kind of the mistake that happens here. So it goes from -infinity, but it stops going down when it changes and starts going up. So that would be the interval from -infinity to -3. This will take some getting used to, but the whole parenthesis notation, when you are increasing and decreasing, singular points can't have that quality. And so you'll get a lot of parentheses. You'll always get parentheses here with increasing and decreasing. But as we gradually go down the table, that symbol starts to change a little bit. And so we'll speak on that maybe a little bit later. The end behavior. Here it's trying to explain what are we doing as an action as we get further away from the origin. And so the left end behavior says that as x travels towards -infinity, going that way, the y values travel towards -infinity, which would be pointing down. And I don't think, really as we go this way, we are starting to, it seems like, get closer to the x-axis again. So I'm wondering if that's maybe a mistake. As x travels left towards negative infinity, the y values actually travel towards 0. And I am not going to take off for this, but in the future we will want to know if it's traveling towards 0 from above in the positive height range or from below. And so the best answer, once you really get good at this, is saying it's going towards 0 from below. And that gives us even extra information about that. Now on the right-hand side, it says that as x travels towards infinity, going out this direction to the right, the y values travel towards infinity. And that is, in fact, what's happening. If I could extend this curve, it keeps going up and up and up, and eventually that curve is even above the table that's here. And so the heights keep on climbing for the rest of time. So that looks good, and this is true. So I'll put a smiley face. All right, so just a little bit of an issue there with the negative infinity on the left hand and behavior. All right, now for the positive and negative intervals. These will go together. Domain and range will go together. And then whether or not something's a function is kind of a third separate question here. We are talking about positive and negative intervals. And it says the first thing from -1 to infinity, those are y values, which I don't think that we are talking about with this quality yet. Any interval is going to be an x value type of notation. So this should be an x and an x, like I said up above. From -1, if I look at that point, this is kind of where we would be intersecting or interacting with the x-axis. From that moment onward, are these heights all positive heights? And the answer to that would definitely be yes. So I will go ahead, I will highlight these are all up and above. The example I use for these is airplanes, and so that yellow region would be airplane territory. So that looks good once you correct the y. So I'll put quotations around false because the numbers are fine, but it should be x in front, not y. So frowny face there, but smiley face here. Okay, the second thing, the negative intervals, these would all be below the x-axis, so they have negative heights. It says from negative infinity, the beginning of time, all the way up until +1. +1, keep in mind, is over in this section of the graph. But we already said this couple of units has positive heights, so it can't have positive and negative heights. Unfortunately, that's weird. So I think the issue with this problem is that it's not supposed to be +1. It's really supposed to be -1. All right, so the graph itself is negative. It's below the water. And actually that left-hand side will stay below the water, which kind of goes back to this end behavior type of idea. It's always just skimming below the water, just under the surface. But it transitions and it changes colors at what particular x value? Well, at x equals -1. So that's why that's false. So from negative infinity in time to -1. Now occasionally, you may get brackets here. And a bracket would just mean that, hey, this point, this coordinate, if there's an end point, that end point is an airplane. It is a positive heighted y value. And so then you could include that value. We don't include it here, and that's because the height is 0. Is 0 a positive number? Nope. Is 0 a negative number? No way. 0 is kind of the separator and the boundary between those two. Moving on to the domain and the range. Domain refers to the x values and how far the graph travels left and right in the x direction. And so it is traveling towards negative infinity. It is traveling towards positive infinity, outwards and outwards. So this one looks good to me. The range is that idea but flipped to look at the y values and the heights overall. Where does this graph live? Going down and up. And so if we look downwards, there's not an arrow that's going to continue to dig deeper and deeper. The lowest this graph ever travels is down here at -2. So -2 is the number that shows up here within this set of y values. Otherwise, we are going towards infinity because this arrow, as I said earlier, just goes up and up and up forever. So from -2 on the floor to infinity on the ceiling, notice that there's a bracket here. And that again is because we have a solid point that we could stand on and include as a potential y value. So that looks great. Domain and range, awesome job. Is this a function? They say it's not because it decreases and increases. Now, kind of a bad answer because they say no, the function decreases and increases. And if they're saying it's not a function but then calling it a function, that means they don't really understand what's going on. So decreasing and increasing has nothing to do really with being a function. Functions mean that you don't have an x value producing too many different answers. An x value can produce one or none of the answers. It can't produce 2 or 3. What would happen is you would have an x value like 4 right here producing a height of 2 or producing a height of 4 simultaneously, which is impossible for a function to do. That's just what we look for when you're talking about functions. So that kind of quality can be hunted for, I suppose, if you use what's called the vertical line test. So the vertical line test makes sure that there's only ever one dot intersecting this laser beam if you scan across, essentially. I don't think we're ever going to get double dots. It passes the vertical line test. So is this a function? The answer would be yes. Each x value creates, sorry for my sloppy handwriting, it creates at most one y value. You are allowed to create no y values. That happens with functions. But you aren't allowed to create too many y values. And so that's a distinction we'll continue to talk about throughout the year. But all of these qualities are things you can talk about with a graph, and they're going to keep showing up throughout the year because it's important for you to understand these characteristics. They give you things to talk about. So hopefully that helped if you were struggling a little bit on some of the intervals and maybe some of the other key features. We'll catch you later.